Imagine something hurtling through the vast, dark emptiness of space for billions of years. This traveler has journeyed from a star system far, far away, long before our own sun and planets were even born. Now, it has finally arrived in our cosmic neighborhood, bringing with it secrets from another part of the galaxy. This isn't science fiction. It's the incredible true story of a newly discovered object named 3I Atlas. It's a real-life space adventure happening right now. This cosmic guest is giving scientists a rare peek into the building blocks of distant worlds, and it is traveling at a speed so immense it's hard to even picture. This object is a time capsule from the distant past. On a clear night on July 1st, 2025, astronomers using a special telescope in Chile, part of the Atlas survey, spotted a faint smudge of light moving across the sky. At first, they thought it might just be another comet, one of the many icy bodies that orbit our sun. But as they tracked its path, they noticed something extraordinary. This object was moving way too fast, over 210,000 kilometers per hour, and its trajectory was not a gentle loop around the sun like our local comets. Instead, it was following a path that proved it came from deep space, from beyond our solar system entirely. It was an interstellar visitor, only the third one we have ever confirmed. This cosmic wanderer was officially named 3I Atlas, with the I standing for interstellar. It is a true alien in our solar system, but not the kind you see in movies. This alien is a giant, icy remnant from a star that is not our own, offering a message from the cosmos. As it gets closer to our sun, it's beginning to warm up and release gas and dust, creating a huge, glowing cloud around it called a coma. This activity is what allowed scientists to spot it from so far away. The discovery sent waves of excitement through the science community, kicking off a global race to study this unique object before it disappears back into the void. Unlike the previous two interstellar visitors we've seen, Oumuamua and 2I Borisov, 3I Atlas is much bigger and brighter. Its coma, the fuzzy atmosphere around its solid core, has been measured to be almost twice the diameter of our entire planet, Earth. The solid nucleus at its heart is estimated to be several kilometers wide, making it a truly substantial piece of another star system. This makes it a much easier target for our telescopes to study in detail. It's like instead of finding a tiny pebble from another country, we found a giant boulder, full of clues about the place it came from, giving us an unprecedented opportunity. What makes 3I Atlas so incredibly special is what it's made of. Think of it like a cosmic suitcase packed with ingredients from its home. When scientists pointed the powerful James Webb Space Telescope at the comet, they were shocked by what they found. The comet is incredibly rich in frozen carbon dioxide and contains a surprising amount of nickel, along with lots of water ice. However, it has very little carbon monoxide, which is a common ingredient in the comets that belong to our own solar system. This strange recipe tells scientists that 3I Atlas formed in a very different environment than our own planets and comets did, a place much richer in carbon. This unique chemical makeup is a huge clue for astronomers. The high amount of carbon dioxide suggests that 3I Atlas was born in a protoplanetary disk, a giant spinning cloud of gas and dust around a young star that was very different from our own. It's a direct sample of the materials that build planets in other parts of our galaxy. Scientists are also amazed by its age. They estimate that 3I Atlas could be over 7 billion years old. That means it's older than our sun, older than Earth, and older than our entire solar system. It has been traveling through space for an unimaginably long time, carrying ancient secrets with it. Because it is so old, 3I Atlas is like a galactic archaeological discovery. It's a pristine relic from the early days of our galaxy, preserved in the deep freeze of interstellar space. Studying it is like a historian finding an untouched artifact that tells a story about a long-lost civilization. This comet gives us a direct look at the chemical conditions that existed in our galaxy billions of years ago. It helps us understand what the universe was like closer to its beginning. Every particle of dust and every molecule of gas escaping from this comet is a piece of a puzzle about how stars and planets come to be. The journey of this interstellar comet is as amazing as its composition. It was likely flung out of its home star system by the gravitational pull of a giant planet, sent on a lonely voyage across the Milky Way. For billions of years, it drifted through the cold, dark void between stars. Now, its path has accidentally crossed ours. It will make its closest approach to our sun around October 30th, 2025. before swinging back out into deep space, never to return. This gives scientists a very short window of time to learn everything they can from this fleeting visitor. It's a once-in-a-lifetime chance to study a piece of another world up close. The discovery of 3I Atlas has triggered one of the most ambitious observation campaigns in the history of astronomy. It's an all-hands-on-deck moment for space science. NASA and other space agencies around the world are pointing their most powerful instruments at this cosmic traveler. The James Webb Space Telescope is using its infrared eyes to analyze the comet's chemical makeup, while the Hubble Space Telescope has captured stunning images of its teardrop-shaped tail and glowing gas cocoon. These two legendary telescopes are working together to paint a complete picture of this object, from its composition to its structure, revealing its secrets one observation at a time. It's not just Webb and Hubble on the job. A whole fleet of spacecraft is getting in on the action. NASA's SPHERE-X mission measured the size of its enormous coma, and the TESS satellite actually spotted the comet starting to become active months before it was officially discovered. Even missions that were designed for other purposes, like the Lucy and Psyche spacecraft heading to asteroids, are being redirected to catch a glimpse of 3I Atlas as it flies by. Down on Mars, the Curiosity and Perseverance rovers are even trying to spot the comet in the Martian sky. It's a truly solar system-wide effort to study this visitor from every possible angle. The information pouring in from these missions is helping scientists test their ideas about how planets form. Some theories suggest that comets like 3I Atlas could act as cosmic seeds. As they travel between star systems, they could deliver water and organic compounds, the building blocks of life, to young, forming planets. By studying the exact ingredients of 3I Atlas, we can learn if it carries the right stuff to help kickstart life on another world. This discovery could help us understand not just how planets are made, but also how the necessary components for life might spread throughout the galaxy, a truly profound question for humanity. For all the amateur astronomers and space lovers on Earth, 3I Atlas offers a special, though challenging, opportunity. The comet won't be bright enough to see with the naked eye. However, starting in December 2025, after it passes behind the Sun, people with backyard telescopes, at least 8 inches in diameter, might be able to spot it as a faint, fuzzy patch of light. This allows people all over the world to feel connected to this grand cosmic event. It's a reminder that our solar system is not isolated. We are part of a vast, dynamic galaxy. And sometimes, visitors from that galaxy come to say hello. This incredible discovery of 3I Atlas is much more than just finding another space rock. It represents a major leap forward in our ability to explore the universe. For centuries, we could only study the objects within our own solar system. Now, thanks to improved telescope technology like the Atlas survey, we are starting to find and study materials from other star systems. This opens up a whole new field of science, studying the galaxy, not just by looking at distant starlight, but by directly analyzing pieces of it that come to us. It's like the universe is mailing us samples, and we are finally learning how to read the return address. Each interstellar object we find gives us a new piece of the galactic puzzle. Oumuamua was a strange, rocky object, while 2I Borisov looked more like a typical comet. 3I Atlas is different from both, with its huge size and unique carbon-rich composition. Together, they show us that there is a wide variety of objects drifting between the stars. As our detection methods get even better, scientists expect to find many more of these interstellar visitors in the coming years. Each one will tell us something new about the diversity of star systems out there and help us build a more complete story of how our galaxy evolved over billions of years. The story of 3I Atlas is a powerful lesson in curiosity and exploration. It reminds us that there are still so many mysteries waiting to be uncovered in the cosmos. Every new discovery, no matter how distant, teaches us more about our own origins and our place in the universe. Are the building blocks of our solar system common or rare? Could life exist in the star system that 3I Atlas came from? This comet may not answer all these questions, but it points us in the right direction and inspires us to keep looking, to keep asking questions, and to keep exploring the great unknown frontier of space. Ultimately, 3I Atlas is a time traveler, carrying a message from the ancient past and from a distant home. Its brief visit to our solar system is a gift, offering us a glimpse of what lies beyond our familiar cosmic shores. It shows us that the galaxy is a connected place, where materials are exchanged between stars over eons. This discovery expands our understanding of the universe and fuels our imagination for what else is out there. As 3i Atlas continues its journey and eventually fades from our view, the knowledge it leaves behind will stay with us forever, shaping the future of astronomy and our collective human story.